Hello, today we'll be talking about elasmobranch conservation. Now we talk about conservation of elasmobranchs, and that's not to say that the holocephali aren't also in need of conservation or aren't threatened in some manner. We just happen to know a lot more about sharks, so this is a very shark-oriented discussion. But a lot of what we talk about can also be applied to those holocephali as well as the rays, which we'll talk about briefly as we cover these topics. So the first thing we're going to talk about is fear in sharks and how that kind of perception affects the way we treat the sharks and the way we relate to the sharks. In the shark attacks, that's kind of related to this idea of fear in sharks. Look at some of the issues that sharks face, the pressures, everything from shark fin soup to some of the other fishing dilemmas that we have, the fishing pressures involved with sharks. And then we'll end with a discussion of the shark protection, looking at some of our conservation efforts to improve the numbers of sharks we have. So when we look at the conservation, fear is the first thing that we have to deal with. And we have to deal with this kind of idea of the demonization of sharks. And we have Jaws to thank for a lot of this, right? There was the book, but the movie really put it out where people could see it. The idea that you could be peacefully swimming and there was this giant killer of the deep waiting to attack you. And that's what it was doing. It was hunting people down. And that kind of made people wary of sharks and looked at sharks as being the enemy. And even books of the time, so we have Sharks of the World. So the movie was about 1975. Sharks of the World, this came out in 1985, and you would think it would be a fairly unbiased view of sharks and just kind of give you the general information. We'll look at an excerpt and you can see what you think. So here, this is from chapter 1, right? This is Sharks Great and Small. And we start right off, honed to perfection as a killing mechanism by 350 million years of evolution. The big killer shark is magnificently adapted to its role as an assassin of the ocean depths. Yeah, we're a little biased here. The sleek, streamlined body, the batteries of needle-sharp teeth, the glaring eyes that miss nothing as they seek a glimpse of possible prey, the quivering snout with nostrils questing for the scent of food. Every centimeter of a typical shark is designed and proportioned for just one purpose: to kill. You've already got an idea of the tone of this book, what the author's view is of sharks in general. And it goes on. Not all sharks are monsters capable of biting a man in half, however. Such creatures are relatively rare. A good-sized shark might measure perhaps 4.5 meters, 15 feet, and would live mostly on fish, not excluding other sharks. A fish of this size could comfortably take a man's arm or leg into its maw and hew off a limb with no more concern than a child might bite into a licorice stick. Or rip out a mouthful of flesh, leaving a gaping wound hemorrhaging into the ocean. So see, not all sharks are killers. Some are not big enough to actually bite you in half. They'll just rip off your arm or leg instead. So see, some sharks are actually pleasant. And then it goes on to talk about other sharks. It actually does say that not all sharks are evil. Well, it doesn't quite say evil. We have small sharks, right? Those aren't going to bother us. And some of our largest sharks, those are the planktivores, right? We've talked about those that are in here. We've got the whale shark talked about here, the basking shark, and they're not a threat to people at all unless you're in a boat. But then we come back to our ferocious predators, the great white shark, talking about how it can easily run to over 6 meters in length, and the jaws bearing those rows of triangular teeth as much as 8 centimeters tall. And it mainly eats fish. However, a 180 centimeter, that's a 6 foot tall, roughly a 2 meter man, swimming in the sea would be a snack of appropriate proportions for such a monster, and the great white has a fully deserved reputation as a man-eater. So it kind of gives you the view of how sharks were looked at. There's something that's going to attack you if you're in the water. They're actually hunting humans down as a food choice, or at least a snack in this case. And we do have to look at the giant sharks. So the idea of how big is big when we're talking about sharks. And you can go online, you can find pictures of this, the two gentlemen that were out just fishing with their, rods and reels in the ocean, and one of them snagged a great white shark and it came out of the water to, I guess, eat the entire boat based on the size of this. So this is most likely a doctored picture, not actually one that's caught, and it's not to scale either. But a lot of people look at this and that's what they think, right? That sharks do get this big and they're actively attacking the people. Our maximum size for sharks, we've talked about this when we looked at those giant elasmobranchs. Those are our planktivorous sharks. We have our whale shark, 12 meters, possibly up to 15 meters, but we know the 12 meters. Basking sharks measured at 9.76 meters reliably, but possibly as big as 12 to 15 meters, getting up there near the whale shark in size. Any way you look at it, they're really big. But what about some of our more carnivorous species, the ones with the sharp pointy teeth that could bite us or rip off our arm or hew us in half, whatever he said in his little story? The great hammerhead has been reported at 6.1 meters, but a verified length is only 5.5 meters. So it's a slight difference there, but if it's verified, that means that we're confident that that's an accurate measurement. Tiger shark, another one of our large sharks, has been reported at 7.4, 9.1 meters, but it's been verified only at 5.9 meters. Again, that's still a big shark, right? A meter is just over 3 feet long, so it gives you an idea of how big some of these sharks are, even the verified ones. And one more, the shorefin mako, reported around 4 meters, but it's only been verified to 3.3 meters. And of course, if we're looking at the size in the sharks, we do have to go back to that white shark. The longest reported measurement for a shark was 36.5 feet long, which is 11.1 meters. And we can round our 36.5 feet up to 40 feet, and that makes it 12.3 meters. So this was kind of the standard number that most people would report for how big a white shark could get. But when some biologists actually checked the jaw measurement as a scale for the body size, you can do this with white sharks, right? We've caught enough of them to know that the jaw size is in relationship to the size of the body. The jaw suggested this was a 16.5 foot long shark, and that suggests that maybe there was just a typo when it was entered, right? Instead of hitting the 1, someone accidentally hit a 3, and our shark suddenly got much larger in size. The largest reliable measurements for a great white shark, well, the longest is 5.944 meters, so that's 19.5 feet. So that's a little bit longer than this original big shark. And the heaviest, which I believe was a different specimen, was over 3,000 kilograms. That puts it at over 7,000 pounds. Now remember back when we were looking at the Sharks of the World excerpt, the great whites can easily run to over 6 meters in length. Might have a little problem with that if the longest was just under 6 meters. I don't think they're easily running to that size. It does make you wonder about how reliable the information is presented from the biologist in that book. I should say the author of that book. And we have to also remember that they're not born as these giant man-eater killers. They're born quite small. They're about that meter. Remember, the meter is kind of thought to be the magical size for sharks. Once you get to be about that big, you don't have to worry as much about the predation from other sharks. Though if you're dealing with some 6-meter ones, I don't think a meter is very safe either. But they're born small, about a meter long, 100 centimeters, 13 kilograms, so just under 30 pounds. And then over time, if they're allowed to live that long, they're going to reach a much larger size. And that's that typical growth curve we talked about, right, where at first it's going to be fairly steep. And then after that first year or so, it kind of slows down, doesn't level off completely, but the growth curve is definitely more flattened. And this brings us to the idea of shark attacks. So going with this idea of fear that there's these giant, great big sharks out there with lots of little sharp, pointy teeth that are waiting to attack us. And so this is a graph done by the University of Florida. And in blue are the non-fatal shark attacks. And then on the top, you can see just a little bit that shows you the red fatal. These are the fatal shark attacks. So there are some, but the majority of attacks are non-fatal. It shows maybe a slightly increasing trend, but that could be related to population levels, right? As we go from 1990 to 2007, or better reporting of incidences. But you can see the majority of attacks that are occurring are not fatal. That doesn't necessarily mean I want to be attacked by a shark. And when we look at the map, there's all sorts of statistics on shark attacks, right? And I'm not even sure what year this is for or how many years this is for, but it shows you what you would expect, right? That the states that are near the water, especially those that are near the warmer parts, right, like Florida and California, have a higher level of shark attacks. You're not really seeing too many shark attacks here in North Dakota, and that's probably because there aren't too many sharks there. So it's what you would expect where people go in the water and go in the water more. We have Hawaii there as well. We would see more of those shark attacks. And when we look at the map for the world, and again, I'm not entirely sure what these numbers stand for. I couldn't figure it out, whether it's for the year or what their count is or even what year it's related to. The warmer places that have kind of more of that coastline, we see more of those attacks. So not as many in Asia, but a lot more in the US where we've got the coastline, South America, we've got the coastline, Africa. So there are shark attacks. Yes, it does happen, but does it happen at the level that we think? It seems to be whenever there's an attack, it gets blown up by the media as a, there's sharks out there, be careful, they're attacking us, they're trying to kill us all type information. Sharks attack us, but we do a pretty good job of attacking sharks as well. And one of the main reasons for harvesting sharks is to create this delicacy of the shark fin soup. And what we have are these like noodle-like things in here, and that's that ceratotrichia. Remember those cartilaginous filaments that are the fin supports in the shark fins? That's what we're doing, what we have here, and you can see we can use the shark meat in a variety of different ways. Shark finning is generally not a very good thing for the sharks because usually what they do is they just cut off the fins and then the rest of it is wasted. And we've got a couple of lovely pictures to look at this. You can see the guy there actively cutting off the fin. You see a whole row of sharks here, some with fins removed. It looks like some that still have some of their fins on. Another giant pile of sharks that have just been finned. And then this room here, which just looks like a warehouse full of sharks. And I know these are kind of depressing pictures, but really this one to me is worse. It was labeled as a living finless shark, so it's on the ocean bottom. It's alive, so it's able to still get water through its gills, but it can't swim at all because it doesn't have its fins. There's been a lot of regulation of this. There's been a lot of outcry where people are demanding that it not be served anymore, no more shark fin soup, and it's had an impact on the market so that there's not as much of a demand. And there's been regulations passed that say that if you're going to take the fins off the shark, you have to take the entire shark. There's no cutting off the fins and throwing the shark back in the water. So therefore, at least the rest of the meat gets used for something, and perhaps we're taking less sharks overall. And direct fishing for the sharks is one issue, but we do have other fishing dilemmas. And this is things like bycatch, and then the economics of sharks. So sometimes it's not targeted bycatch, but sharks bring in some money, so if we get them, then we'll keep them and sell the shark and the shark parts and just make a little bit more money as well because we've accidentally taken those sharks out of the water. And one of the problems is trawlers, right? That they throw the big net out there and they just scoop up everything that they get, and you do get a lot of bycatch that way, a lot of the non-directed species you're after. And again, whether they're being incidentally caught with the targeted species, there may be some incentive to land the sharks because of the shark parts can have high prices in some markets. We also have the tuna purse seines. So the way that they go out and they fish for tuna, right? They have the big seine, they put it down and they take the boat around and they're trying to trap all the tuna on the inside like that. And they have the dolphin safe nets, so the dolphins can kind of jump and get out of there and they still keep the tuna. It doesn't work for sharks very well though. So it does help the dolphins, but not the sharks that can also be in there as well. So they're targeted or caught incidentally in the long line, trawl, purse seine, gill nets, drift nets, all of these various nets that are out there. And like most of the other aquatic wildlife, we do have two kinds of nets that we have to deal with. We have the directed ones, the ones that are out there and we're actively using, and then we have the ghost ones that they're called, the ones where maybe the part of the net has ripped off or it's been lost, like the entire net has been lost at sea and it's just floating around catching animals in it, but no one's ever going to remove that net and take it out of the water. And then we also have a whale shark fishery, which is kind of bizarre to think about. We've talked about how there aren't really very many whale sharks out there just naturally, right? They're a large animal, they're slow reproducing, so you're never going to have high numbers. But before 2008, in Taiwan, there was a legal whale shark fishery. It was small, but the thought is that from 95 to 2008, they had over 800 whale sharks that they processed. That's still a lot of animals when you don't have a large population to start with. And it folded eventually due to international pressure that we shouldn't be taking those. But we found evidence in 2004 that suggests that there was fish processing plants in China that were processing up to 600 of the whale and basking sharks every year. And that's deeply concerning because that's one fishery plant. Perhaps there's other plants out there. And these are rare species, like we've said, the whale sharks and the basking sharks are two big planktivores. And so their populations are naturally low, and they probably aren't going to be able to handle the pressure of a fishery for very long. Yeah, Southeast Asia, that's where the whale fishery was. So there are alternatives to the fisheries, and some of these locations are realizing it, that we can kill a whale shark and we get one set of money for it. Or if we open it as a tourism attraction, we get a lot more money because multiple people will come and swim with that one whale. And when they come to see the whale, they're also going to stay in the hotels, and they're going to shop in the markets, and they're going to eat at the restaurants. So it has a bigger, wider economic footprint that it makes. So some places are realizing, similar to like with the African wildlife, right? We can shoot the lion, or we can have people pay us money to come and look at the lion. So it's the same idea here. And there's all sorts of different places you can go, right? You can go swim with the killers of the deep there in your little cage, or you can say, who needs a cage? I'm going to swim right next to the sharks. Lots of different choices for this, and all of these, we even have a Shark Diver magazine, are encouraging people to keep sharks alive and use them as a source of income, a marketing tool, without killing the shark. So it's kind of win-win all around. The people that live there are making more money than they would if they were killing the shark and harvesting them, and the sharks are hopefully doing a little bit better with that local conservation as well. When we talked about the life history strategy of the sharks, we could see how vulnerable they are, especially those large individuals. They're apex predators if you're like the great white shark, the larger hammerheads, the larger tiger sharks. But even our big sharks, our whale sharks and our basking sharks, they're all present in low numbers. And that's the idea. If you're at the top of the food chain, if you're in that very specific niche, you're not very numerous to start with. Because you're not numerous, well, you have slow growth and long maturation, right? It takes a long time to reach adult size. There aren't very many of you around, so therefore it takes a long time for you to reproduce, right? You're trying to replace yourself for a stable population, right? Each adult will have one of their young make it to adult size. So there's no reason to have lots of young. So we see this long gestation period. So we have 1 or 2 well-developed young that we give birth to. Not all. We have that whale shark that has 300 babies, but apparently most of those don't make it to adult size, or we'd have lots of adult whale sharks. A long reproductive interval, so you may be pregnant for a long time, the egg may take a long time to hatch, but then the female also takes a long period of time to recover from that and be able to have a second reproductive event. And we see the small clutch size again with this. If you have this kind of lifestyle, you tend to have 1 or 2 young at a time. And one of the problems that we didn't mention was there's not a refuge for these sharks, right? They are wide-ranging, they're found throughout the world, but they don't have a place to hide. Most of the species don't use deep water, so there's no place that they can go to kind of escape the predation pressure. So it's not like there's isolated populations somewhere that won't be affected by some sort of fishery. And then the other problem is their large range, right? You can't protect a fish that swims away. It's hard if North America says, okay, we're not going to hunt the whale sharks. The whale sharks are fine as long as they stay by the North American coast, but once they decide they're following that plankton somewhere else, now they're open to the predation risk, the fishery risk. Well, we are aware of this. We've been doing what we can for shark conservation. In 2008, we have our red list of threatened species, and we've got our over 1,000 species of our cartilaginous fishes. So they had a bunch of workshops to look at the species against that kind of criterion. What do we need to know about a species in order to list it? And so they looked at all the different information for the various species. They're looking at their distribution. Where do we find them? Where do they occur? Their population status. Do we know if it's stable or increasing or decreasing? Their life history, all those things we just talked about, right? Are they going to be able to quickly reproduce their number, replace their numbers, or is this something that's going to take a long time? Looked at the habitat they lived in. Is the habitat threatened? And we looked at other threats for each of these species. And what they were trying to do is rank each of the species and see where they fall on this little list here. Are they least concern? That's kind of what we're hoping for most of our animals, right? That we're not really worried about them. Or, near threatened means we need to be aware. But once we reach this vulnerable stage, that's when we're starting to get really concerned, right? We move past the little concern. Vulnerable, endangered, critically endangered. Because the next step after this is extinct in the wild, and there really aren't that many of those giant sharks in captivity. So this is what we're concerned with, is hitting that vulnerable level, and we wanted to see how many of our species fall in there. And what we found was that we've got about a quarter of them that are least concerned. So that's pretty good, right? A quarter so that we don't have to worry about. And this other maybe 30% or so, these are the ones we start to get concerned about, right? We've got near threatened and then we hit that vulnerable, and these are our critical ones here that we're most worried about. But the most shocking thing on this graph is this gray part. 47% of our sharks, that's 47% of our cartilaginous fishes, almost half, we don't know enough about to make any conclusion. And that's amazing when you think about it, that about half we know something about, and of those, half of them are okay, and the other half, right, this quarter are ones we need to be concerned about. But we have 47% we don't know anything about, not even know where to start with those. We'll start by looking at the whale shark. So we've talked about the whale shark before, right? It's one of our large planktivorous sharks. And it was previously listed as vulnerable, but after the scientists looked at their data, they upgraded it to endangered, or downgraded it to endangered. I'm not sure which way you'd look at it. It's worse. To be vulnerable, your population decline is about 30% or so over 3 generations. But the data suggests that the whale shark actually is declining at 40 to 90% over those 3 generations. So what's the primary threat? Well, that's targeted capture by fisheries in areas where they seasonally aggregate, right? So they're following the plankton, so you can kind of find them in certain spots at a certain time of the year. And we see this in Taiwan. Whale shark meat is readily available there. It's reported to be the most expensive shark meat available. The sharks caught in Taiwan are small in size compared to how big whale sharks can get. When you have a fishery and you start catching smaller and smaller fish, it suggests that you're probably overfishing what you have there. So that does suggest that the fisheries are having a large effect, a large impact on the shark population. We also don't know the effect of other things in the environment, like noise on sharks. So we know how whales, right, they hear like we do, but sharks, their hearing is a little different. So it's unclear if there's some sort of sound effect that we have on sharks, maybe keeping them away from preferred habitat, preferred area. Boat strikes we do have some information on, but not a lot. They do spend a lot of time at the surface or close to the surface, right up there feeding on plankton. So they're vulnerable to boat strikes, and there have been reports of scars on their back showing that there are some collisions between them. And then lastly, the habitat. So you tend to think, well, they're giant fish and they swim everywhere. So how does habitat really affect them? And when they linked declining whale shark numbers in the late 80s and early 90s to high rates of coral destruction at the same time. So there seems to be an importance of coral habitat for the sharks. And if you have a healthy coral reef, you're going to have lots of fish, lots of invertebrates, lots of things spawning, which are going to be adding to the plankton levels. And that may be something that is important for the survivability of the sharks. So again, it's one of those, there aren't a lot of them, so they're hard to study and know where they're going and what kind of habitats they use. So we do see that by looking at the data closer, we can change that the whale sharks are now endangered. Basking sharks are vulnerable. So they're listed that, right, their population is going to be declining about 30% or so. They're primarily threatened by more of an incidental capture. There is some targeted capture for shark fin soup. I mean, you've got a giant fin there, right? Those fins are huge. So there is some targeted capture for that, but a lot of it is just incidental take. We'll move on to our megamouth. He was put at least concern, previously data deficient, but since the first time they ranked him as data deficient, there's been some more caught and a little bit more information. It's taken as bycatch sometimes, but it's found in deeper waters. So of all of the large elasmobranchs that we've talked about, this is the one that's found at depth, and we tend to not have as big of an effect on the deep water fishes. We do get some of them in our bycatch, but not as much. So he's actually less affected by humans and isn't really part of a targeted fishery. So least concern for the megamouth. The angel shark, on the other hand, is considered critically endangered. So these different species, they lie on that sandy bottom during the day, right? They'll go down on the bottom and they might even bury themselves in the sand, and then they come up at night to feed. And that makes them easy to capture. So if you're looking for them as a targeted fishery, then they're easy to find, but they're often caught as just as bycatch with a variety of different fishing gear, whether we're trawling or we've got nets or something out there in those shallow waters where we're going to find the angel shark right on that sandy bottom, that they get picked up as bycatch. They weren't really considered any sort of commercial interest. There wasn't really a fishery for angel sharks. But in 1978, a fish processor in Santa Barbara, California decided that we could do angel sharks. This would be awesome. And they caught like 300 metric tons of sharks the first year. The fishery quickly collapsed. The sharks just don't replace themselves fast enough. So it's not like fish, some of the bony fishes where you can go out and you can capture a bunch one year and they're going to reproduce so fast and grow quickly up to adult size that you can then fish them again the following year. It just doesn't work that way for most of our cartilaginous fishes. Now they're protected, regulated. The manta ray. So we will talk about something that's not a shark for a little bit. The manta ray was previously near threatened, but now it's decided to be classified as vulnerable. The declines are at that 30% globally. Before it was thought to be much less than that. And the part of the problem is they're just big and slow, right? It's the same issue we have with the other sharks. If you're trying to find a whale shark and you know where they congregate at certain times of year, they're found near the surface. They're big and they're slow, so it makes them an easy target. And we do have target fisheries for this species in several countries: Philippines, Mexico, Mozambique, Madagascar, parts of India, Brazil, Tanzania, Indonesia. And they use a lot of the different parts and export part of it too. There's a big demand actually for the branchial filaments that they have in there, but they'll also go for the meat and the liver and other parts of the fish. And one of the things they've noticed as they looked over the data for the rays is we seem to have two different types of life history, life pattern. In Hawaii, there are groups of rays that rarely leave the area that they're found in. So they're considered to kind of almost be residents. They move around and find their food, but they're found in the same general area. Parts of the population are known to move off and seasonally appear, so they're kind of a more migratory. And a lot of the other populations are known to be migratory. So there's this idea that you've got two different types of populations. If you're not aware of what kind of manta rays you have locally, whether they're a migratory species or a residential species, you're not going to know how to manage for those, right? So if you've got ones that are moving in seasonally, you're going to have a different idea of how to manage versus ones that are there permanently. If you start to fish a population that is a permanent resident population, you're quickly going to fish them all out, and there's not going to be any more coming in. So it's something that management has to keep in mind when they're looking at fisheries, is also that lifestyle of the fish. And we do have to throw our great white shark in there as well. He's listed as vulnerable. So they don't really have a lot of commercial value, right? People aren't out fishing them to turn them into like canned great white shark, like we have our canned tuna. But it's a popular sport for big fish, big game anglers, right? They have this fearsome reputation, right? The killers of the deep. And so it's kind of has legendary status as this big apex predator. And so people want to fish them just to fight them and to be able to say, I caught a great white. So we see the fishery for sport and as well as for parts of them. There's a market for their jaws, especially where people just want to buy the great white shark jaw with the great big teeth, the individual teeth, as well as their fins. So they're considered vulnerable currently. And there's other sharks that we can just kind of throw into a general category. It's really hard to get data on some of these species, those that are wide-ranging or those that are small in numbers. So wide-ranging migratory species are severely threatened by overfishing and incidental and targeted capture. There's not a lot of regulation on the high seas, so if you're out there and you've got your trawl nets out and you're scooping up a bunch of fish, you may be taking a lot of sharks by mistake, but you don't really care that much because you're just trying to get the fish that you want and the other ones get thrown back in. And I have things like the short fin mako here, which are listed as vulnerable. Those far-ranging species are not the only ones that are threatened. Ones that just have a narrow range, like the Brazilian guitarfish or Harrison's dogfish, are also highly threatened due to capture, right? If you have a narrow range, it's actually easy to almost fish out all of them. And habitat degradation. If you're found in a very specific habitat type, then you're vulnerable to any sort of issue that can come up with that habitat. Pollution, degradation, a change in that habitat. We see this in our sawfishes. All 7 species of sawfishes are critically endangered. When we look at the red list for the sharks, we find that 47% of those sharks and their relatives are data deficient. And that's because it's really hard to study the sharks in the wild. They live individually, they live over large ranges. You can't just sit there and watch them go by. You can't follow them very easily. And we don't really know a lot about the reproductive biology of many of these species. If you don't know the reproductive biology, then it's hard to get any idea of their life history, right? Do they reproduce lots of young? Do they reproduce a few young? Are their young vulnerable? Are the adults vulnerable? How do we even manage a population that we don't know anything about? And so little is known about the major effects, the major threats on the populations. But then comes the issue. Can we assume that they are as threatened as the species we have data for? And that's an interesting question because we don't know anything about them. So do we protect them as if there's only 3 of them left and that we should do everything we can to protect those that are there? Or do we assume that maybe they're more like that 25% or so that are okay, that we could fish in a regulated manner? So it's hard to know the answer to this question, whether you want to be conservative about it and protect everything we have, or whether you think that they could be managed in some way. And part of it is we just need to get more information on the sharks. As we get more kinds of tags that we can deploy, that helps us at least figure out where they're moving to. But as we know, small sharks, medium-sized sharks, those are the harder ones to find and to tag, to know what those juveniles are doing. So our summary of our major threats to sharks, well, we have overfishing and capture and bycatch, right? We've talked about that. Pollution and habitat loss, we didn't talk about that directly. That one just gets kind of depressing. Sharks live in water. For a long time, we believed that dilution was the solution to pollution, so we could just take all of our wastes and throw it in the water and it would be diluted and everything would be fine. We know that that's not the case. We see issues with plastics in our water. We see persistent chemicals in the waters as well. And it's unknown what effect these have on the fishes. And it may not be so much that they have a direct effect on the adult large sharks. It may be somewhere down that food chain. And if you disrupt the food supply at the bottom, right, we know that that has a cascading effect up through the food chain. And habitat loss, that's something that most of us are familiar with to some level. Those young juvenile sharks, like the other juvenile fishes we've talked about, they like those shallow, warm coastal waters. We like the shallow, warm coastal waters too. It's where we like to build our beach houses and where we like to take our vacations. And unfortunately, we tended to degrade the habitat there quite a bit, keeping the beaches the way we think they should be. It's where we have our pollution, it's near shore. So there's some definite habitat loss there, as well as, like I mentioned, with the coral reef habitat loss. That has a cascading effect again through the food chain. Climate change, I don't know if we want to even get into that one. Climate change is most likely going to have some serious effects for all of the aquatic organisms out there. We're changing potentially the ice caps, right? We're changing the weather patterns that could change your phytoplankton, your zooplankton populations, which is important for some of these larger sharks as well as for the smaller fish. Changes in your ocean flow patterns could mean that the larvae, the juvenile fishes, end up somewhere else. It could move the food supply somewhere else. But one of our big threats is fear. We've done a lot to combat this fear, at least in the US, where most people are kind of aware that yes, sharks are something to be worried about, but maybe they're not something that we have to go and kill before they kill us. So what can we do? Well, more and better information helps. And actually, that's where I think Shark Week has been helpful. It's informed and educated a lot of people on sharks, and we think of them now as more of a wild animal and something that's ferocious and powerful, and maybe something to be feared, but not something that we have to feel like we have to go out and hunt and eradicate. So education is definitely helping with that. New market incentives, so the idea that perhaps there's some other way you could use that shark. The idea of ecotourism is definitely helping to protect sharks, and with sharks, the other fishes that share that habitat. High seas governance, this one gets a little harder where we want to have some kind of international ability to kind of see what's happening with the sharks, ability to protect fishes across all of the oceans. Improved fisheries technology, well, that's going to help let us know how many fishes we have and where they are. The more data we have, to some extent, the better we can actually control what we have out there and what effects we have. Catch limits, protections of aggregations when they're coming together to spawn and to mate. Perhaps that's not the best time to catch them. And maybe some other ideas. Maybe you have some ideas as to what we can do to help kind of change the view of sharks and help protect sharks in some manner. Unfortunately, this is not an open class and we can't discuss this one. This is always a fun topic to talk about. So we'll end with this idea, which I think is a nice contrast to how we started with that quote from the Sharks of the World book. This is the most dangerous animal in the world. It is responsible for millions of deaths every year. By its side, a great white shark swims peacefully. And to me, that kind of shows this attitude change we've had, where we started with this idea of fear of sharks, that they're man-eaters, they're out there to kill us, and kind of that we should kill them before they get us type of mentality, to this idea that sharks are something to be protected, that we are the ones that are doing most of the killing, and that we need to be aware of our choices and to mitigate our decisions where we can. So this kind of was our discussion on the conservation of sharks. I hope it wasn't too depressing. That you can see that we're aware of what's happening as a community, right? As the people that protect wildlife, we're aware of what's going on, and that we're doing what we can to try to save the species before they reach those kind of really critical areas. So as you review this, if you have any questions or comments, things you'd like to talk about, please send me an email and let me know. Thank you.